Hello students, welcome back. Today we're going to be doing the related rates. We're going to be combining the implicit differentiation and some of the derivatives formulas to solve implicit differentiation problems. So let's take a look at one example. So it's going to be our first example, which is air is being pumped into a spherical balloon so that its volume increases at the rate of 100 centimeters cubed per second. How fast is the radius of the balloon increasing when the diameter is 50? Right, so what are we given? We're given that the volume, right, the key thing, the volume increases over time, right, with the rate of 100 centimeters cubed per second. So how can we write it down? So to write it down, we can say, well, given dV over dt, right, where V is the volume. So the rate of change of volume over time is actually a constant of 100 centimeters cubed per second, right? And what we do know, right? What do we do know? So we know that we want to find, right, the rate of change of increase of a radius when the diameter is 50. So that means we want to find dr over dt, right? So the rate of change of the radius, right? How fast is the radius increasing? So that means we know that the radius, right? If the diameter is 50, radius is half of the diameter. So it's going to be 50 over 2, which is equal to 25 centimeters. Okay, so how do we use that? How do we use implicit differentiation in this problem? So we could use it by remembering how to find a volume of a sphere, right? We're going to assume that the balloon is spherical. So the formula, right, volume of sphere is going to be equal to 4/3 times pi times radius cube. Okay, now we want to take a derivative, and it's going to be an implicit derivative, right? So we're going to have dv over dt, which is going to be d dt of 4/3 times pi times r cubed. So that's actually, right, going to be the same thing as dv over dr times dr over dt. So we were going to have, so derivative of the volume with respect to radius is going to be 4 pi r squared times dr t. Okay, so we do not know dr over dt, so let's solve for it. So dr over dt is going to be equal to 1 over 4 pi r squared times dv over dt. Okay, so we have everything here. Let's plug in. So 1 over 4 pi times 25 squared times 100. So if we simplify, we're going to get 1 over 25 pi. So the radius of the balloon is increasing at the rate of 1 over 25 pi, or about 0.0127 centimeters per second. So that's the rate at which the radius of a balloon is increasing, right? The diameter would be increasing at twice the speed, right? Because it's radius times 2. All right. So essentially, this was our first related rates problem. Let's go ahead and move on to the second one. So the second one's going to be a classic one. So it's going to be about ladder. So a 10-foot ladder, long rest against a vertical wall. If the bottom of the ladder slides away from the wall at the rate 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet away from the wall? So, right, let's go ahead and draw what's happening. So we have a wall and we have a ground. Okay, and we know the rates at which they are sliding. Well, one rate at which we're sliding. So we know that it's sliding at the rate in the x direction at 1 foot per second. Okay, so how can we find? So we know that we have a right angle. So what equation does relate the sides of the right triangle and the hypotenuse of the right triangle? Pythagorean theorem, or I'm going to call it PT, Pythagorean theorem. So Pythagorean theorem will state that x squared plus y squared is equal to 10 squared. Okay, or in other words, x squared plus y squared is equal to 100. Okay, so now we got to use the chain rule and to take the derivative, right? Here we're thinking about x being a function of time and y being a function of time, right? So we have to go ahead and take a derivative with respect to time. Okay, d dt. So we're going to have 2x times dx dt plus 2y times dy dt, which is equal to 0, right? Derivative of a constant is 0. Now, we do not know dy dt, so let's solve for dy dt. So dy over dt will be equal to negative x over y times dx over dt. Okay, now plugging in the numbers, we will have, so x over y, right? Let's see, we know that when x is equal to 6, right, by Pythagorean theorem, it will give us the following. So when x is equal to 6, so 6 squared plus y squared is equal to 10 squared. So that means y is equal to square root of 100 minus 56, which is equal to square root of 64, which is equal to 8. So that means we can plug in, right? So we're going to have negative 6 over 8 times 1, which is equal to negative 6 over 8, or simplifying, we're going to get negative 3 over 4 feet per second. Right, so the rate at which the ladder is going to be falling down, right, to the ground is going to be 3/4 feet per second, so a little less than a foot per second. All right, so it's going to be sliding down with that speed. All right, perfect. So now let's take a look at next problem. So let's take a look at a conus problem. So cone problem. So now, right, next example is going to be as following. So a water tank has a shape of an inverted circular cone with base radius of 2 meters and height of 4 meters. If water being pumped into the tank at the rate of 2 meters cubed per minute, right, volume per minute, find the rate at which the water level is rising when the water is 3 meters deep. Okay, so let's go ahead and take a look at the drawing of such problem, right? So it would look like this. So we have a cone, we have the radius. So we know, right, we know that the volume, dV dt, right, this is a volume, has a rate of 2 meters cubed per minute. Okay, what are we trying to find? We're trying to find the rate at which the height is increasing, right, dH over dt, and we know that height is 3 meters. Okay, so we need to know the equation, right, equation of the volume for the cone. And the equation is volume is equal to 1/3 times pi r squared times height. So from the similar triangles, right, if we think about it in 2 dimensions, we have 2 similar triangles. We know that the ratio between radius to height is 2:4. That means radius is equal to half of the height. Okay, so by plugging this in, we're going to have the volume is equal to 1/3 times pi times height over 2 squared times height, which is equal to pi over 12 times height cubed. Okay, now we are able to differentiate it with respect to time, because we are looking for dH dt, right? So dV dt is going to be equal to pi over 4 times h squared times dH over dt. So solving for dH over dt, we will have 4 over pi h squared times dv over dt. So now plugging the numbers in, dh over dt, we will get 4 over pi times 3 squared times 2, which is equal to 8 over 9 pi, which is about 0.28 meters per minute. All right, perfect. So, essentially, some of the strategies that are recommended, right, that useful to know of how to solve the related rates problems. So, essentially, first, most important thing is to read the problem carefully and draw a diagram if possible. Introduce the notation and assign the symbols to all of the quantities that are functions of time. Express the given information and required rate in terms of derivatives. And write an equation that relates the various quantities of the problems and the things that we're looking for. And use the chain rule to differentiate both sides of the equation with respect to t and substitute the given information to find the resulting rate of change. Right, perfect. So now let's do a short car problem, which will be used same techniques. So example 4. A car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when the car A is 0.3 miles and car B is 0.4 miles from the intersection? Okay, so here's going to be the drawing, right? Car A, car B, they heading towards each other. So we're interested in essentially the Z hitting the point C, right? So how can we relate X, Y, and Z? Pythagorean theorem, which would state that Z squared is equal to X squared plus Y squared. But this time, Z is also a function of time. So if we take a derivative, we have to use the chain rule, right? We're going to have 2Z times dz over dt is equal to 2x dx over dt plus 2y dy over dt. Perfect. And then that means if we solve for dz over dt, we will have 1 over z times x dx over dt plus y dy over dt. Okay, so we're given by the problem x is equal to 0.3, y is equal to 0.4. So we can use Pythagorean theorem to find z at this moment, right? So it's 0.3 squared plus 0.4 squared is equal to z squared. So z is equal to 0.5. Okay, so now plugging in. So we know that dx dt is equal to negative 50, right? Because we're traveling west. West is going to be negative. And then for y, we're going to have dy dt is going to be negative 60, right? So negative 60. So we're going to have negative 60 miles per hour. All right. So we will have that dz over dt is going to be 1 over 0.5 times 0.3 minus, so times negative 50 plus 0.4 times negative 60, which will end up getting us negative 78 miles per hour. All right. Perfect. So, and let's take a look at the last problem for today. So, we will have example 5. So, there is the statement. So we have that a man walks along a straight path at the speed 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searching light rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, so let's actually show the picture here, right? Specifically for this problem, right? So that's how it's going to look like. So we have a man walking and the searchlight is moving. So we have a right triangle projected. So we know, right? What do we know? We're given that dx over dt, right? So the rate is 4 feet per second, right? Because that's the speed at what man walks along the path. Okay, and then the d theta dt, we do not know, right? But we know that x is 15, right? That's what we know, when x is equal to 15. So, by using some of the trigonometry here, right, we know we can try to find the relationship. So we know that tangent of theta is going to be opposite over adjacent. So it's going to be x over 20. So that means x is equal to 20 times tangent of theta. So that's going to be our main equation here. Okay, so let's go ahead and take a derivative of it. So dx over dt is equal to 20 times secant squared theta times d theta dt, right? Let's remember the derivative of tangent theta. So, all right, if we solve for d theta, so d theta over dt will be equal to 1 over 20 times cosine square theta times dx over dt. All right, so now by plugging in, we will have 1 over 20 times cosine square theta times 4, which is equal to 1/5 times cosine square theta. So when x is equal to 15, the length of the beam, right, is 25 by the Pythagorean theorem. Okay, so yes, so Pythagorean theorem, we have the length, which we can call L. Okay, so L squared is equal to 20 squared plus 15 squared. So that's equal to, L is equal to 25. So that means if it's 25, then cosine, right, from this cosine of theta, which is adjacent over the hypotenuse, is going to be 20 over 25, which is equal to 4 over 5. Okay, so now final step is to plug in. So d theta over dt is equal to 1/5 times 4 over 5 squared. And that's going to be equal to 16 over 125, which is equal to 0.18 radians per second, right? Since we were not given that in degrees, we are working in radians. So the searchlight is rotating at the rate of 0.128 radians per second. All right, perfect. So that would be it for today's lesson. For our next lesson, we will start on linear approximation and differentials. So we're going to be linearly approximating some of the derivatives. All right, thank you guys, and I'll see you all next time.